Hello, my name is Ardi and we are going to solve problem E3.6 from IRWIN's book. So the question is find V0 in figure E3.6 using nodal analysis. Okay, let's set this bottommost node here as our ground. So the voltage here will be 0. So all of this will be 0, the voltage. And let's name our node here. Let's name this as node VA. And then this node here as VB, and then this node here as VC. Okay, and then let's assume the direction of the current. For the branch with current source, I just follow the arrow, so this will going up and then going to the right. So we'll have this, and this is going to the right. I just follow the direction of the arrow. Good. And now let's just assume the other direction. Usually for the vertical branches, I assume it is going down. And then for horizontal branches, I usually assume it going to the right. Good. And then now let's do KCL at node VA, VB, and VC. Let's do that. Let's do KCL at node VA. Okay, what does KCL say? KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. The only current that goes in is 2IA here. So we'll have 2IA. And then that will equal to this current here, that is VA minus 0, which is VA, divided by the resistance between them, which is 3 kilo ohm. So we'll have VA divided by 3. And then we will have plus this current here. And this current here will be VA minus VB divided by 6. And then this current here is exactly 2 milliampere. So we'll have 2 milliampere here. Okay, the problem here is we have 2IA. Oh, I don't need to write the unit here. 2IA, IA is this current here, which is VB minus VC divided by 2. So let's write that. So we will have 2 multiplied by VB minus VC divided by 2. And that is IA, right? So we'll have VA over 3. And then plus VA minus VB over 6, and then plus 2. Okay, let's get rid all of the denominator by multiplying both sides by 6, right? And what can we do from here? 2 and 2 will cancel out, but then I will have VB multiplied by 6 and VC also multiplied by 6. So we'll have 6 VB minus 6 VC here, and that will equal to, I will have 2 VA and then plus 6 and 6 will cancel out, so we'll have 2 VA. No, not 2 VA. 6 and 6 will cancel out, so we'll have VA minus VB, and then plus 2 and 6 will becomes 12. Good. Now what can we do from here? We will have 3 VA. Let's continue it here. We will have 3 VA. And then minus 1 and minus 6, that becomes minus 7. Minus 7 VB. And then this one will comes to the right hand side. So we'll have plus 6 VC. Then plus 12 will comes to left hand side, but I write it on the right hand side, so we'll have minus 12 here. And I think nothing further that we can do from the node VA, right? We have done this node VA. Let's save this as equation number 1. Okay, now let's continue to the node VB, but let's clean up thing first. Okay, now let's do another KCL, but this time at node VB. Okay, let's do exactly that. KCL at node VB. KCL said that the sum of the current that goes in will equal to the sum of the currents that goes out. Okay, the only current that goes in is this one, and that current is VA minus VB divided by 6. All the other currents is going out, so we put the equal sign here. And this current here is VB minus 0, which is VB divided by 6. Good. And this current here is VB minus VC divided by 2. Okay, multiply both sides by 6. And we will have VA minus VB is equal to, this one will be VB, and this one will be plus 3 VB minus 3 VC. So we'll have VA minus 5 VB and then plus 3 VC. All of that will equal to 0. And nothing further that we can do from here. Let's save this as equation number 2. Good. Okay, now what else that we can do? We can do another KCL, but this time at node VC. Let's do exactly that. KCL at node VC. KCL said that the sum of the current that goes in will equal to the sum of the currents that goes out. Okay, the only current that goes in is this one. So we'll have VB minus VC divided by 2. Oh no, there are another current that goes in, which is this one, which is 2 ampere. So we will have plus 2 here. And that will equal to VC minus 0, which is VC divided by the resistance between them, which is 1 kilo ohm. Good. Now multiply both sides by 2. So we will have VB minus VC, then plus 4, and that will equal to 2 VC. And here we will have VB minus 3 VC is equal to minus 4. Okay, and then let's save this as equation number 3. So now we have 3 equations with 3 variables, right? 1, 2, and 3. The fastest way to solve this is by using calculator. Okay, let's set our calculator as equation solver. Let's set this up. And equation solver is number 5. And 3 variables is number 2. And let's plug the coefficient. So we will have 3, then minus 7, 6, and then minus 12. Good. And then the second equation, we will have VA here is 1, and then minus 5, and then 3, and then 0. Okay, that is good. And then the last equation here, VA is 0, so we have 0. And then minus 3, no, not this, minus 3. That is 1, so we have 1 VB, right? And then minus 3, and that will equal to minus 4. Okay, we'll have the X value is VA, right? So we'll have VA minus 8.571. Okay, let's write that. VA is minus 571, and the unit will be volt. And then what is VB? VB is, what is this? Minus 1.143. Okay, minus 1.143. and the unit here is also volt. And then what is VC? VC is 0.952, 0.952 volt, and that is VC. But VC here is also V0, right? Because that is V0 from the ground, right? So we'll have V0. Let's write it in red maybe. V0 is equal to VC here, VC minus the ground. So I'll have 0. And so we'll have V0 is equal to VC. Therefore, V0 is this one here, 0.952. The unit will be in volt. And that is the final answer for this problem. Let's highlight that. Okay, and that's all for this problem. Thank you for watching. See you in the next video. Bye bye.